Hi everybody, hope you're having a great day. We have a few things to do today. You're going to need your notes. So let's get our notes out and we're going to do that last problem, which looks way more complicated than it is. So we're ready, I guess, for example 8, I think. If not, we'll pick up where we left off last time. I don't remember. So I'm going to start with example 8, which basically says, use the average rate of change over this interval to approximate a value that's not in your table. So what we have in the table is some theta and r values. Remember, f of theta is r. So we are going to find the equation of the line that goes through these 2 points. We have 2 ordered pairs here. We're going to find the equation of the line that goes through those 2 points. Okay? So to find the equation of the line, we're going to do the average rate of change, which we know is like the slope, okay? So our average rate of change is f of, I'll say theta 2, minus f of theta 1, all over theta 2 minus theta 1. So if we call this theta 1 and this theta 2, then we can find our slope, our average rate of change, by taking 2 minus negative 1 and dividing that, oh, excuse me, backwards, excuse me, negative 1 minus 2 over 7 pi over 6 minus pi over 6. Now, I just erased what I wrote. We know from all of our work with lines and finding slope that the order I subtract really doesn't matter as long as I do it the same on the top as I do on the bottom. So since I wrote my formula as 2 minus 1, I'm doing 2 minus 1. So negative 1 minus 2, those are my f values, my function, my r's, minus 7 pi over 6 minus pi over 6. So that's going to be negative 3 over pi, and that is my average rate of change. That makes 6/601. Okay? Now, let's take one of our points. Doesn't matter which one. I'll take this one. I'll just use this one. And I'm going to write the equation of the line. Now, point slope in rectangular coordinates looks like this. Right? Well, for me, my y's are f of thetas, and my x's are thetas, all right? So my equation is going to be f of theta minus, now I'm going to use this first point, so minus 2 equals my rate of change, which is my slope, times theta minus pi over 6. Okay, so again, in rectangular coordinates, I would have x and y. My chart would look like x and y. So just substituting in the polar variable equivalents, I have this equation. So f of theta minus 2 equals negative 3 over pi theta plus, what is that, 1/2? Did I do that right? Okay, now let's move the 2 over. So we have our equation in slope intercept form. Of course it's not, but you know what I mean. Get my f of theta by itself. So negative 3 over pi theta plus 5/2. Now, my job was to find f of 5 pi over 6. So it's like in your chart, now they're throwing in 5 pi over 6. And you need to find the f of theta value. So guess what we're going to do? We're going to take, that's our theta, we're going to take that guy right there, and we're going to plug him in right here. So I'm going to erase some of this so I have some room to work. So f of 5 pi over 6 is going to equal negative 3 over pi times 5 pi over 6 plus 5 halves. So that is going to be, is that 0? I think that's 0. So it says use it to approximate it, and we're going to approximate it at 0. Okay? So, again, it looks crazy, but it is exactly what you've done since you were freshmen. You're writing the equation of a line given 2 points. The points just look a little bit different than normal. Okay. All right, now turn the page, and we're going to talk about what's going on in this graph. Consider the function f of theta equals 5 sine 3 theta. What is the independent variable? What is the dependent variable? I think we talked about this before. The independent variable is theta, because if you were going to evaluate this function, you would need a theta value to plug in. So just like when we have in rectangular coordinates, we have f of x, x is the independent variable. So theta is your independent, and f of theta, or r, is your dependent variable. All right, what shape is made by this? You guys know this. That is a rose with 3 petals, length of 5. Okay? Now, one thing I think I'm just going to pause here for a second, because I noticed it in your homework. Some of you were asked to do a freehand sketch, and you didn't orient it quite correctly. So I want you to pay attention to whether this function is a sine or a cosine. If we put in a 0 for theta, so we're here, right here, this is 0. If we put in a 0, we get 5 sine 0, which is 0. So a sine curve, because the sine of 0 is 0, will not have a petal out here. The petal will be where this equals 5. 5 is the maximum. Where does that happen? Well, you can graph it rectangularly and tell for sure, because you're going to have a hill there. Or you can just stop and think, if I want this to be 1, that's the maximum it can be. If I want it to be 1, then I need to have the sine of pi over 2. So 3 theta has to be pi over 2, which means theta has to be pi over 6. So your first leaf is going to be out there at pi over 6. Okay, so if this were a cosine, the cosine of 0 is 1. So that would plot out here. So you would have a leaf on the x-axis if this were a cosine problem. Okay, I hope that kind of makes sense. You know it's a rose, you know it has 3 leaves, and we need to figure out how the thing's oriented. It is not on the x-axis. It's jutting up here, in this case at pi over 3. All right, well that wasn't the question. What was the question? At what values, oh well here, yeah. At what values of theta does the maximum value occur? Well, the maximum value is going to occur at pi over 6. And then you can go through and do more work like this, or you can just use your common sense. If there are 3 leaves, and they are evenly spaced, always evenly spaced, and one of them is at pi over 6, where are the others? Well, how far apart do they have to be? don't they have to be 2 pi divided by 3 apart? So if the first one is at pi over 6, then the next one will be 2 pi over 3 later. So what would that be? 5 pi over 6? Pardon my drawing. And then where will the next one be? 5 pi over 6, 2 pi over 3 later, which would be 9 pi over 6, 3 pi over 2. So there they are. So where do the maximums occur? The maximums occur at the end of each petal. Okay? And once you find where that first petal is, you automatically know where the rest of them are because they're evenly spaced. All right, the minimum value of R is going to be -5, right? Because the minimum value of sine is -1. Well, where does the sine equal -1? Well, the sine equals -1 at 3 pi over 2. So 3 theta has to be 3 pi over 2. So theta has to equal pi over 2. Now keep in mind that when you put in pi over 2, you're going to get a -r. Where is that point going to plot? Right down here. We already knew that. All right, where is f of theta 0? This is question number 4. Where is f of theta 0? Well, where is it 0? We kind of already talked about that. This is going to equal 0 wherever the sine is 0. So where is the sine 0? The sine is 0 at 0. The sine is 0 at pi. So this is pi. So 3 theta equals pi, and theta equals pi over 3. Where else is the sine 0? At 2 pi. So 3 theta equals 2 pi, so theta is 2 pi over 3. Those are the places where the sine is 0. Now, I have done all of this just based on my knowledge of polars. What if I graphed that equation rectangularly, which is something I've encouraged you to do? It's a sine curve, amplitude 5, period 2 pi over 3. Look what happens if I graph this thing, guys. Look what happens. Didn't we just say that the sine was 0 at 0, pi over 3, and 2 pi over 3? And didn't we say it had a maximum value at pi over 6 and a minimum value at pi over 2? So right there it is. So if all that stuff that I was talking about didn't make sense, look at this. That'll make sense. Okay, now I've kind of sketched it already very roughly, but now let's fill in this chart. So we've got, theta values, and we're between 0 and pi over 6, pi over 6, pi over 3, pi over 3, pi over 2, pi over 2, 2 pi over 3, 2 pi over 3, pi over 6. Oops, I haven't graphed quite enough, so I will graph a little bit more. I need to continue this. Let's see, that's 3, 6, 4. This would be 5, 6. This would be 7, 6. Okay, that's all I need right there. Okay? All right, so I want to know, is R positive or negative? Okay, so take a look at your picture. Remember, R is f of theta, like y. So here we go. It looks like from 0 to pi over 6, it's positive. It's positive, negative, negative. Now I'm talking about sign, plus, minus. That's all. So 2 pi over 3, that's positive and positive. Okay, Now I'm talking about whether R is increasing or decreasing. So let's take a look at our picture. R is increasing. R is decreasing. Now let's just stop right there. I know the picture's right in front of us, but remember what happens to the polar curve or to any curve when you go from being increasing to decreasing. You have a relative maximum. So there is a relative maximum right here at pi over 6. Obviously that's the case, but do you see, can you interpret this value right here? They're both positive, so I'm up here, but on one side of this point I'm positive, or I'm increasing, and on the other side I'm decreasing. That means I have a maximum. All right, what's happening between pi over 3 and pi over 2? What's happening? R is increasing, R is decreasing, R is increasing, R is decreasing. Yeah. All right, we okay with that? All right, now let's look at this right here for a second. These guys right here, both, I'm negative and negative on both sides, but on one side I am increasing, on the other side I am decreasing. Wait, that's not right. Oh yeah, yeah. So I'm changing from increasing to decreasing. On the negative side, so remember, if R is decreasing, or excuse me, if R is increasing on the negative side, then the curve is actually decreasing. F of theta is decreasing here, but that means R is increasing, getting farther away from the x-axis. So I go from being decreasing to increasing on my curve. R is going from increasing to decreasing. That's going to be a relative minimum. Now, why do I not have a max or min here? I'm going from decreasing to increasing. Why do I not have a max or min there? Because R has different signs. R is positive on one side and negative on the other side. That doesn't mean I have a max or min. That means I have a 0. When I'm talking about R being positive and negative. Okay, let's see, something happens here. At 5 pi over 6, I go from being increasing to decreasing. I have another maximum at 5 pi over 6 because both positive, so I'm up here, both points are up here, and on one side I'm going up, on the other side I'm going down. Here, both negative, one side I'm going down, one side I'm going up. There I have my maxes and mins identified. All right, number 8. Jared says that whenever the radius is increasing, the distance between f of theta and the origin is increasing. Okay, let's look at this part of the graph right here for a second. Is R increasing on that interval right there? Now, I'm talking about R. I am not talking about, I'm talking about the distance from the origin now, or from the pole, okay? He says if the radius is increasing, the distance between okay, so that's okay. Let's look at this one. Excuse me, let's look at this one. R, f of theta, is actually increasing on this. The function value is increasing. It says the function value is increasing, but the distance to the origin, or the pole, is decreasing. So if theta, excuse me, if f of theta is negative, then as it can be increasing. It is going up. Y is going up. F of theta is increasing, but the distance to the pole is actually decreasing. We're getting closer and closer to the pole. Unlike over here, the radius, the curve, F of theta is increasing, right? That's increasing, and the distance from the pole is also increasing. So as long as you're talking about positive R's, you're good. But as soon as you come over here and you talk about R's that are negative, as they increase, you get closer to the pole. So the distance doesn't increase, it decreases. All right, find the average rate of change between 0 and pi over 6. Okay, we know how to do that. The average rate of change will simply be f of pi over 6 minus f of 0 over pi over 6 minus 0. Okay? All right, so here we go. We can look at our graph. What's f of pi over 6? We can either plug it in the equation or just look at our graph. F of pi over 6 is 5. F of 0 is 0. So it looks like we have 30 over pi. Okay, and it says, write a sentence interpreting your answer. Okay, what does that mean? That's the slope. That means that on this interval, now we're talking specifically about the interval from 0 to pi over 6. So on that interval, for every radian, or pi radians, for every pi radians we increase, our function value increases by 30. So the ratio of the function value increase and the degree or radian angle increase is 30 over pi. Perfect. All right, backside, check your understanding. Let's see what we need to do over here. I don't know that I'm going to complete that table of values. We have a lot to do today. I don't know if that's worth our time, but let's go ahead and sketch this thing rectangularly. And I think that'll give us our function values anyhow, so we'll have what we need probably. So what have we got here? We have a midline at -2. And we have a positive cosine with an amplitude of 4. So I'm going to go up 1, 2, 3, 4, and 1, 2, 3, 4. It's a positive cosine. So I'm going to go ahead and set these up to 2 pi is my period. All right, so cosine positive is going to start there. Okay. Not my best effort, but there it is. There's my cosine curve. All right, now what do I want to know about that? Well, it says, so function values I could get from here. So, oh, wait a second. Let's find our zeros. They're going to be important probably in the problem, so let's find them. We've got our maxes and mins already, but let's find our zeros where we actually cross the axis. So we'll set this equal to 0. So 4 cosine equals 2, cosine equals 1/2. Where does that happen? Cosine is 1/2 at pi over 3 and 5 pi over 3. Okay, so now I have maybe not all of my function values, but I have a bunch of them. All right, on which intervals, this is question B, on which intervals is this thing increasing? Pi to 2 pi. Where is it decreasing? I'm talking about the function itself. Where is it decreasing? From 0 to pi. What is the maximum value? The maximum value of this function is 2, and the minimum is -6. That makes sense. Is f changing faster between 0 and pi, so the interval from 0 to pi, or the interval from pi over 3 to 2 pi over 3? Now, you might have a thought on that, but we could certainly prove it to ourselves or somebody else if we found the rate of change. That's what it's asking. Are we changing our rate of change faster? Okay, well, I don't know, let's find the rate of change. So for this guy, it'll be f of pi minus f of 0 over pi minus 0. All right, what's f of pi? F of pi is -6. So this one is -6 over pi. Okay? Now, what about this one? Well, this is going to be f of 2 pi over 3 minus f of pi over 3 over pi over 3. 2 pi minus 1 pi. All right, so what's f of 2 pi over 3? Whoops, I don't have it figured out, so I'm going to have to figure it out. So I'm going to plug in 2 pi over 3. So -2 plus 4 cosine 2 pi over 3. All right, what is the cosine of 2 pi over 3? -1/2. So that is going to be -2 minus 2, -4. What is f of pi over 3? Well, that one I know. F of pi over 3 is 0. So that one's going to be -4 over pi over 3, which is -12 over pi. So what was the question? The question was, which one is faster? Which one is bigger? Well, which one of these two numbers is bigger? I'm talking magnitude-wise, not otherwise, magnitude-wise. So it looks like that one. So that we're changing faster in that little interval from pi over 3 to 2 pi over 3. And I think maybe most of you could sense that, because going from here to here, it's a shorter piece of the curve. And if we go all the way from here to here, we have kind of a flattening. It's steeper in this middle part than it is at the top. Up here we have at the top of the hill. So that and this kind of dampen your slope a little bit. So it makes sense that it was faster in there. Some of you might have figured that out, you know, on your own. Okay. All right, now, next, we're going to do the crack the code exercise, all right, which is on the next page. And we're going to, I was just looking through here. I knew this didn't match what I had written on my paper. F of 0 is not, f of 0 is 8. I mean, is 2. So f of 0 is 2. So that's -8 over pi. Yeah, now it matches what I had written down. It doesn't matter. This is still bigger. This is still bigger. But now I've got that right. F of 0 is 2. All right, now we're going to crack the code. No calculator. This exercise, we're going to get as much as we've done together as we can, and you're going to finish the rest on your own. I will publish the answers in Schoology to whatever we don't get done, or maybe I'll just put them all in Schoology. And then next time I see you, whenever that is, whatever your day is, when I see you, we're going to have a quiz. and I am going to pull the problems directly. I'm not going to rewrite them. I'm not going to change the numbers. I'm not going to do anything. I'm going to pull them directly off this crack the code exercise. So by the time we come to class, whatever we don't get done today, right now, you are responsible for looking at the answers, and then we will have a quiz over these, not all of these. I'll just pick a few random problems, write them exactly as they are on here, and that's what you're going to do for a quiz. All right, everybody clear? Good. Okay, so here we go. We're on Crack the Code, set A. When graphed in the true or false? When graphed in the complex plane, the complex number -2 plus 7i is in quadrant 2. Yes. The complex number 4 minus 4i can be written in this form. Well, in order to answer that question, I need to find my radius and my angle. So here's my radius. There's 4 minus 4. My radius is, let's see, 16 plus 16 is going to be 4 root 2. And this angle is pi over 4, but my actual angle would be 7 pi over 4. So my answer is 4 root 2 cosine 7 pi over 4 plus I 4 root 2 sine 7 pi over 4. Is that what you have down here? Yep. Now, I've distributed the 4 root 2 through, they got parentheses, but obviously that's the same answer. It can be written either way. So that one's true. The polar coordinate 6, 2 pi over 3, this is polar, can be used to represent a point in the complex plane with a positive real component and a negative imaginary component. Well, that's false. And there's two ways that you can think of that. First of all, you can actually find the real part is 6 cosine 2 pi over 3, and the imaginary part is 6 sine 2 pi over 3. Remember, x is real, y is imaginary when we're talking about complex numbers. Or you can just stop and think about, where is that point? That 2 pi over 3 is over here. And if you're over here, x is negative and y is positive. So the real part is negative and the imaginary part is positive. So that's a false. When graphed in the complex plane, the complex number -8i is on the horizontal axis. Now, -8i is the same as 0 minus 8i. Would you agree with that? And where is that plotted? This is an x, this is a y. That's plotted down here. So this is the polar axis right here. This is, maybe we've never talked about that, so it's a good thing I'm doing this. This is the polar axis. So this is not plotted on the polar axis, is it? It's plotted on the vertical axis. The angle that corresponds with this is 3 pi over 2, not 0 or pi. So that's a false. The point on the complex plane described by the polar coordinates 5 cosine pi, that represents a real number. Oh, maybe I better write it the right way. So 5 cosine pi plus I sine pi. Does that represent a real number? Well, again, you can do this by working out, by finding x and y. So what is x? Always, x is r cosine theta, and y is r sine theta. So you can physically work that out. Or you can just stop and ask yourself, where is this number? This number is over here, 5 units away from the pole at an angle of pi. And the question is, it represents a real number. Well, think about that for a minute. Does that represent a real number? Yes, because what's its y? 0, and that means there's no I, so that means it's just a real number. This would be 5 plus 0i, because that's the point 5 comma 0. Excuse me, negative 5 comma 0. Negative 5 plus 0i, a real number. If you're on the polar axis, you're real. If you're on the vertical axis, you're pure imaginary. This is a pure imaginary number here, negative 8i, no real component. All right, next. The polar coordinates can be used to represent a point in a complex plane with a positive real and a positive. So in other words, that point, negative 9, 5 pi over 4, is it in quadrant 1? Because if it's going to have a positive real and a positive imaginary, the question is it in quadrant 1? Is it positive, positive? Well, remember, when you change the sign on R, the angle changes by pi. So if we back up pi, wouldn't this be a pi over 4? And isn't pi over 4 in quadrant 1? So that's a true statement. X and Y would both be positive for this number. And again, you can always find X and Y. So if you don't know, if you don't have a clue what I'm talking about, find X and Y. So X would be negative 9 cosine 5 pi over 4, and Y would be negative 9 sine pi over 4, 5 pi over 4. And when you evaluate those, they're both going to turn out positive, which tells you you are in quadrant 1. Positive real, positive imaginary. All right, next. Somewhere in the picture, there's P. The complex number P can be written in rectangular form as 3 plus 2i. No, false. It's 3 minus 2i. Look at it. See it down there in quadrant 4? All right, next. K can be written, where's K? All right. K can be written as 3 cosine pi over 4 plus I sine pi over 4. No. No. If R is 3 and theta is pi over 4, you are in quadrant 1. You are not point K. In order to get that angle, pi over 4, into quadrant 3, you'd have to have a negative R. And we don't. So that's a false statement. In that problem, 3 cosine pi over 4, I sine pi over 4, that's in quadrant 1. And finally, the last one, W represents a purely imaginary number. No, it doesn't, because doesn't W have a real component? 1 comma 4. W is 1 plus 4i. That's a real. Remember, if you're going to be pure imaginary, you have to be on the vertical axis. Okay, so what we're supposed to do now is total up our true statements. 1, 2, 3, 4, I think, for that one. All right, let's do the next one. Let's do set B together. Here we go. An alternate name for the polar point negative 3, 7 pi over 3 is 3 pi over 3. All right, let's talk about this for a minute. If I'm going to change the sign on R, then how much does the angle change by? The angle changes by pi. So this would be the same as this. Would everybody agree with that? I change the sign on R, my angle changes by pi, 3/3. Now, if I want to get all the way down to there, then won't that change it back to negative? Isn't this the same as this? Yes, these are the same. That's false. These are the same. When your angle changes by 2 pi, then your radius doesn't change, because 2 pi is just around. Only when your angle changes by pi does your radius sign change. All right, so that's false. Number 2, the 0.2 comma 3 pi over 2 becomes this in polar coordinates. X equals r cosine, y equals r sine. That's a false statement, guys, because this is going to be 0, but what's this going to be? -2. So that's a false statement. Rectangular coordinates mark locations with horizontal and vertical components, whereas polar coordinates mark locations with a distance and an angle. True. That's it. A polar point with a negative angle represents a reflection across the pole. No, a polar point with a negative r is a reflection across the pole. But what does a negative angle do? A negative angle just means instead of going up, I go down, right? Yeah, that is not a reflection across the pole. So that's another false. All right, how about this next one? Looks a little confusing. R theta and negative r, theta plus 3 pi, represent the same point. Now, we haven't really talked much about this, but in a way we have. If you want to reflect, if you want to change the sign on r, then your angle has to change by pi. So certainly this would be the same as this. If I change the sign on r, my angle is going to change by pi. Now, tell me about the relationship between this and this. This is adding 1 pi. This is adding 3 pi. What does that extra 2 do, that extra 2 pi? Absolutely nothing. Adding 2 pi brings you back to the very same point. So aren't these two at exactly the same spot? Yes. And it would be if it were a 5 or a 7 or anything. Now, how about this point? Are these two at exactly the same point? Absolutely. Adding 2 pi changes nothing. So that is a true statement. That is a true statement. Next one. If a point has Cartesian coordinates such that x is positive and y is negative, then I'm in quadrant 4. X is positive, y is negative. I'm in quadrant 4. Then that point has polar coordinates between 3 pi over 2 and 2 pi. 100% true. True. The graph described by the equation theta equals pi over 2. We haven't talked about that type of equation, but I think you can figure it out. Okay, I'm not going to draw a bunch of circles. It's a polar equation, and it's theta equals 3 pi over 2. Now that means that for every, if you're like plotting points, for every theta, it's the same, 3 pi over 2. For every theta, I mean, every radius has that theta. So we have a point at 1, 3 pi over 2, 2. How about -3, 3 pi over 2? Well, that would be plotted up here, right? So if we put all those points together, what do we get? We get that line right there. So that is the line where theta equals 3 pi over 2. If r is positive, you're down here. If r is negative, you're up here. There's the line. That's all the points that have a theta of 3 pi over 2. So what's the question? Has a slope of 0. False. It has a slope that's undefined. It's undefined. Okay. The circle given by 10 cosine theta. Now we have talked about this one. Again, we're not doing this with a calculator, folks. This is totally no calculator. You need to know what that looks like. It's a circle. situated over here to the right of the y-axis, right? If theta is 0, then r is 10. This is the point 10. So the diameter of this circle is 10, which means the radius of the circle is 5. And the center of the circle, if I'm talking about it now in rectangular vocabulary, the center of the circle would be at 5, 0. So the equation of that circle would be x minus 5 squared plus y squared equals 25. That's a false statement. X squared plus y squared equals 25 has a center at the origin. That circle would look like this. This is not centered at the origin. All right, given a radius and an angle, the x coordinate is given by cosine and the y coordinate is given by sine. False, false, false. X is r cosine theta, y is r sine theta. That's how x and y are given. The only time that x is cosine is if you're in the unit circle. In other words, the radius is 1. Okay, so how many we got there? Truths, counting truths. 1, 2, 3 truths. Okay, I'm going to do half this next one, and then we're running out of time here. So you're going to finish this on your own. I'm going to post the answers sometime, not today probably, but sometime I'll get the answers posted, and you'll have them, you'll have them by Monday. You'll have your answers by Monday. All right, so number 1, r equals 4 sine 6 theta represents a rose, yep, but not with 6 petals. This rose is going to have 12, so false. R equals 6 sine 6 theta, or 4 sine 6 theta, same equation, represents a rose with polar axis symmetry. Okay, now be careful. Polar axis symmetry would mean it has leaves that do this kind of thing, okay? And it can have other ones too, but it has leaves with that kind of thing going on. This is a sign. Does it have leaves that look like that? No, it does not. Oh, wait a second. No, it doesn't have leaves that look like that, but are they symmetric? That's the question. Not are they on the axis, are they symmetric? So let's figure out where the leaves are. So where is the sign 1? The sign is 1 at pi over 2. So I'm going to have a leaf at pi over 12. 6 theta is pi over 2. So I'm going to have a leaf at pi over 12. And I've got how many of them? I've got 12 of them. So how far apart are they going to be? They're going to be pi over 6 apart. So I'm going to have a leaf at 1/12, 3/12, 5/12, 7/12, 9/12. I hope I'm adding right. 11/12, 13/12, 15/12, 17/12, 19/12, 21/12. I know some of these reduce, and 23/12. That should be 12 of them, okay? Now what I need to ask myself is, I need to look at these angles and see if I have symmetry. Like my first one is here at pi over 12. I'll call this pi over 12. I need to have one right here. Right here, if I'm symmetric across here, I have to have a leaf right here. Well, do I? Well, that would be negative pi over 12. which is the same as 23/12, isn't it? So aren't these symmetric? All right, let's pick another one. Let's try 7 pi over 12. This would be 7 pi over 12. All right, so it would have to have one right here. If it has symmetry across the polar axis, it would have one down there. Well, what would that be? This is pi over 12, so that would be 11 pi over 12? Or no. This is 3 pi over 2. That would be 17/12. 17/12. So do I have one at 17/12? I do. So this guy and this guy have symmetry. 7 pi over 12 and 17 pi over 12 have symmetry. So it looks like that's a true statement. I haven't tried every single one, but it looks like they're all going to match up nicely. So we have symmetry across the polar axis. So in other words, this leaf has a mate right here, and this leaf has a mate right here, and so on and so on and so on. All right, so that one's true. All right, last one. R equals -3 cosine theta is a circle to the left of the y-axis. All right, let's look at it. R equals -3 cosine theta. Truly, that is a circle to the left of the y-axis. That part's true. Does it have a radius of 3? No, it doesn't. This is 3. So the radius is actually 1.5. So that one is a false. All right, I want you to finish this page and the next page on your own. Check your answers, and next time I see you, we'll have a little quiz with a few of those questions verbatim. All right, have a great day, everyone.